Hi, I'm Jake Southern, and I'm an industrial engineering major.
I'm Michael Guillermo, and I'm an industrial engineer.
I'm Christian Vargas, and I'm a mechanical engineer.
I'm Emily Zabrowski, and I'm a mechanical engineer.
I am Jonathan Schultz. I'm a fifth-year electrical engineering student here at RIT.
We are the MSD team working to improve the window latch assembly process for Hilltop Business Services.
Hilltop Business Services currently uses 20 employees to assemble window latches by hand. It is a three-piece assembly consisting of an outer carrier, a metal cam, and a lock to hold the cam in place. Hilltop has tasked us with fully automating this process to reach a cycle time of 3 seconds or less.
Success for a project is simple. We want to design an automated system that assembles one window latch every 3 seconds. This system needs to be able to run without local interference, be safe to use, and require little maintenance. In order to reach a cycle time of 3 seconds, we have broken the assembly process up into 5 separate stations. Each station will take 3 seconds or less to complete, resulting in an output of a fully assembled window latch every 3 seconds.
Station 1 of the system consists of a hopper, a bowl feeder, and a pick-and-place robot for placing the first component, the carrier. The carriers are loaded into the hopper by the operator. The carrier travels into the bowl feeder, which orients the part. At the end of the output track of the bowl feeder, the part is picked up by a pick-and-place robot, which places the carrier into a fixture on the rotary table. The fixture constrains the carrier for the following assembly steps. The rotary table then indexes to its next position. The next station places the cam into the carrier. This station consists of a bowl feeder, a vision system, a SCARA robot, and a rejection chute. We use a SCARA robot at this station to give our system one more degree of freedom, since the cam is cylindrical in design with a tab that must be in the proper orientation to assemble into the carrier. The cam is inspected for defects by a vision system along the track of the bowl feeder. If a defect is detected, the robot will place the cam into the rejection chute. Otherwise, the robot will rotate the cam to the proper orientation and place the cam into the carrier.
Moving on to Station 3, this is where the cam will be rotated 90 degrees to clear the way for the lock to be placed later. We will use a pneumatic actuator to accomplish this. This will have a cylinder drop onto the cam, hold it in place, rotate it 90 degrees, and then release the cam. This brings the partial assembly onwards to Station 4, where the lock is placed. Similar to Station 1, the station contains a hopper, a bowl feeder, and uses a pick-and-place robot to grab the lock and place it onto the assembly. By this stage, the fixture contains a completed assembly. The final station is where the completed assembly is removed from the system. A pick-and-place robot will be used to grab each assembly and drop it down one of two chutes down to a box of finished products. One chute will be used until its corresponding box is full, at which point parts will start being deposited down the other chute while the first box is being replaced.
The last major component of this project is our customer handoff. We will be handing off all of our current progress to Cavalry Robotics. They will work closely with Hilltop to take this design from a concept to a physical and serviceable machine. This ties into the unique aspect of this project, that we are not actually building and prototyping the entire automation system. Rather, we have had to adapt to focus on concepting and building relationships with our soon-to-be successors to ensure our customer receives a fully functional system beyond the scope of our MSD project. We would like to acknowledge and thank everyone that has helped us with this project, from the RIT MSD office to Hilltop and Arc of Livingston, Wyoming. Especially, we would like to thank Cavalry Robotics for being our automation house subject matter experts. We're going to take this project beyond the scope of our team. And we would like to thank Applied Robotics for helping us with our end-of-arm tooling.